Section 2.4 is about parallel and perpendicular lines, which means that we're done learning different formats. We've learned 3 forms of a line: slope-intercept form, point-slope form, and standard form. Jot them down if you need a refresher. But what we're going to do in this section is take what we know about lines and how to write lines and determine if 2 lines are parallel or perpendicular. So, parallel lines. And underneath Part A, look for relationships, take some notes about parallel lines. They have equal slopes. The exact same slope. Because think, the slope is the rise over the run, how the line moves. And we know parallel lines never intersect. They never intersect. They never are going to cross. That means they move the same way. They have the same slope. They have the same rise over run ratio to be parallel. So if you're looking at 2 equations of lines, and here we have an example, 2 examples, 2 lines, y equals 5x plus 3 and y equals 5x minus 7. And what we know about slope-intercept form is the number in front of the x represents our slope. And what do we notice about the slope of these 2 lines? They're both 5. That means that they have equal slopes and they are parallel lines. Now the other type of special 2 lines we can have are perpendicular lines. Perpendicular lines intersect to form a 90-degree angle, and they have what we call opposite, reciprocal slopes. Opposite means opposite sign, so like plus or minus, one's positive and one's negative. Reciprocal means that their fractions are flipped. So the way we can think about this is a flip-flop. We've got to flip the sign, flop the fraction. There's 2 parts that make them completely opposite reciprocals. So I've got 2 examples for you down here, and that's in our slope-intercept form where the number in front of the x represents the slope. So the slope of this first equation is 2/3, while the slope of this second equation is -3/2. This is an example of opposite reciprocals. Notice they have opposite signs. One's positive, one's negative, and they have a flopped fraction. Here the 2 is in the numerator with the 3 in the denominator. And in our next example, the 3 is in the numerator and the 2 is in the denominator. It is a true flip-flop. So when you are jumping into this section and you're trying to determine if lines are perpendicular, ask yourself, are they a flip-flop? Do they have 2 parts that are changed, as in the sign is flipped and the fraction is flopped? 2 flips, a flip-flop. Let's jump into example 1. Example 1 asks us to write the equation of the line in slope-intercept form, so it told us what format it wants it in, that's important, that passes through the point -3,5 and is parallel to a given line, y equals -2/3 x. So let's dissect this real quick. They're telling us to write an equation of a line. Okay, we know how to do that. And it tells us a point that it passes through, and it tells us that it's parallel to a line. Well, what did we just learn about parallel lines? Parallel lines have equal slopes. So the equation we're given is y equals -2/3 x. And we know we need to be parallel to that. AKA, we need to have the same slope. So let's pick out the slope. The number in front of the x is the slope. So the slope of this line is -2/3, which means the slope that we want is also going to be -2/3 because we want the same since we are parallel. But notice what happens here. They gave us a point and we know that we need to have the same slope. So naturally, if we're given a point and we know the slope, we probably want to use this point slope form since that's really good for when you have a point and you know slope. But they told us that we need to write our answer in slope-intercept form. In this example, I'm going to show you how to start in point-slope form to write the equation, but how to convert that to slope-intercept form. So let's take this information and write it in point-slope form. Let's do our y, and now our opposite y1. Our y value is 5, so the opposite would be minus 5, equals m, which is negative 2/3, times x, and now we need minus x1, which means opposite the x value. The x value was negative 3, so the opposite is plus 3. Okay, we've technically written the equation of the line. If it did not tell us how to type in our answer, we would be done. But sadly, it says we need slope-intercept form, which, just a reminder, slope-intercept form is y equals mx plus b, aka the y is on its own and there's no parentheses. So all we need to do is we need to get rid of our parentheses. We can use some distribution. Let's start with that. Let's distribute. We're going to end up with y minus 5 equals, if you do negative 2/3 times x, that's just negative 2/3 x. But if you actually multiply negative 2/3 times 3, that just becomes minus 2. And now we're really close. If you're comparing these formats, all we have to do now is get this y by itself, aka we got to undo that plus 5. So I'm going to add that to the other constant term. And now I have y equals negative 2/3 x, and if we calculate negative 2 plus 5 is a positive 3. And look at that. I went from point slope form to slope-intercept form just by distributing the slope and then doing an opposite operation to the number next to the y. If your problems ask for a specific format, use this example to help you get from point slope form to slope-intercept form. Let's do another example. Example 3, we're skipping 2, says write the equation of the line that passes through the point 4, 5. Okay, we have a point, and is perpendicular to the graph of y equals 2x minus 3. Okay, so what I'm noticing here is it did not tell us what format to write it in. So that means I can write it in whatever format is easier. And since they gave us a specific point rather than a y-intercept, point slope form is probably going to be the easiest. But now I need to be perpendicular to, they gave us y equals 2x minus 3, and we want to be perpendicular to that. So that's when we use the knowledge that we learned that perpendicular lines have opposite reciprocal slopes. All right, so let's pick out the slope of the line we were given. It's the number in front of the x. This line has a slope of 2. Again, we want to be perpendicular to that. So we need to flip-flop it. I left out the I. We need to flip-flop it, which means the slope of the line that we're going to graph needs to be the opposite sign, because that's what the flip means, flip the sign. This was a positive 2, so I know now my slope needs to be negative, and I need to flop that fraction. If you notice, this isn't even a fraction, it means it's just being divided by 1. So if I flop that, that's going to be 1 divided by 2. And now the slope that I need to use to make that line perpendicular is negative 1/2. I now know my slope is going to be negative 1/2, and I can fill in the rest of my equation of the line with the point that I was given. Y, let's do the opposite of y1. This y was 5, so that's going to be minus 5, equals negative 1/2 times x, and then we do the opposite of x1. This x was 4, the opposite of that is minus 4. And since the problem did not tell us exactly what format we need to be in, any format is acceptable, so we can be done with point slope form. Your last example is just going to ask you to determine, are the graphs of the equations parallel, perpendicular, or neither? So just a reminder, if they're parallel, they're going to have the same slope. If they're perpendicular, they're going to have a flip-flop slope. So if they're not the same and they're not a flip-flop, then they're neither. So let's look at A. It gives us two equations. It gives us y equals 2x plus 6 and y equals 1/2 x plus 3. Let's pick out those slopes. The slope of this first line is 2. The slope of the second line is 1/2. Are they the same? No. Are they a perfect flip-flop? Did it flip the sign and flip the fraction? No, it didn't flip the sign. So this would be neither. They're not the same, and they're not a perfect flip-flop. Let's do another one. For this equation, it gives us y equals negative 5x. Ooh, and it gives us 25x plus 5y equals 1. Ooh, it gave us something in standard form. Finding the slope of this first line is easy. It's the number in front of the x when we are in our slope-intercept form. So that slope is just negative 5. But in this equation, we're in standard form, and we don't know a quick way to find the slope until now. To find the slope from standard form, it is m equals the negative a value over the b value. So let's fill that in. The a value is 25, so the negative opposite a value would be negative 25, divided by the b value, which is 5, because remember, standard form is that ax plus by equals c, and negative 25 divided by 5 is negative 5. Well, guess what? If this is negative 5 and this is negative 5, then those are the same, which means they are parallel. Woohoo! All right, very last example is in your practice and problem solving, and it actually gives you two lines on number 19, and it says use the slope of the lines A and B to show that they are perpendicular to each other, which it's telling us that they need to be perpendicular. So if perpendicular, we need a flip-flop, which means opposite sign, opposite, undo that, opposite sign, and a flopped fraction, like 3/2 becomes 2/3. So let's check it out. Let's calculate the slope of these lines. Line A, let's find 2 points on it. We've got our y-intercept, and it intersects here. So the slope of line A, let's calculate it. Let's calculate the rise. 1, 2, go up 2, go over 1. So that slope is just 2. Let's calculate the slope of line B. Find 2 points. We can do that intersecting point. Let's find another one. That's another one. It goes down 1. It goes over 2. Down 1 means negative, so that'd be negative 1 over 2. And let's check it out. Are they a perfect flip-flop? So let's compare. Remember that that 2 is secretly over 1. So is 1 positive and 1 negative? Yep, we flipped the sign. Did we flop the fraction? 2 over 1 becomes 1 over 2? Yes. So yes, they are truly perpendicular because they have opposite reciprocal slopes.